So this is a tutorial on the bookwork, Chapter 4, starting with 4-1 Aristotle and motion. Basically, they thought the idea of natural motion, without answering them in complete sentences for you, is that the objects were just simply going down to where they naturally wanted to be. Violent motion was something that was forced. It was a push or a pull, and it was force motion. It could be the wind, anything that forced something to move where it didn't want to move, as opposed to natural motion was the natural resting place. A rock wanted to come to rest on a ground, and then you had to push it or pull it to move it. So obviously that's contrary to Newton's laws, and it just does not work. Copernicus was one of the first guys to talk about how the Earth was not the center of the universe, right? He tried to put the sun in the center of the universe, or at least the center of the known universe at that time, and everything else going around the sun. So he got a little bit of trouble for that because it was quite controversial. So Galileo said that a force was any push or pull, and that friction was something that is always going to oppose this push or pull, or oppose motion. So the friction is caused by microscopic discrepancies in the surface. So if you're going along a wax floor, it's nice and shiny, but it still has some microscopic discrepancies. There is some friction, and the smoother it is, the less friction they have. If you could have something that was 100% smooth, which we do not have, we could get friction down to 0. Impossible. Galileo did a thought experiment with the little balls that were rolling down these inclines, and he said in the absence of friction, it would go back up to where it started. So then he made the idea, what if you went down and then just went straight? It couldn't go back to where it started, could it? So the idea definitely was a thought experiment that it would just keep going forever and ever and ever. So good idea. Couldn't prove it. So Newton came along and he expanded upon these first thinkers who weren't really, I guess, wrong. They were just going in the right direction. So Newton's first law of motion is called the law of inertia, and inertia is that things want to keep doing what they're doing. The Greek word for that is laziness. Newton's first law from the book, and you can copy that down from page 46. I'll let you do that. Basically, you want to go in a straight line at constant speed, and that's the idea we call constant velocity nowadays, unless we got forces acting on it. So what is needed to start an object moving, and the best way to put that is an unbalanced force. So forces, forces can, but you have forces on you all the time. But we need unbalanced forces, meaning that there's more one way than the other. And same thing, what is needed to stop an object from moving? Also an unbalanced force that's opposite the way of the motion. So if we have a force that way, and then we have a teeny tiny force that way, then it's going to accelerate that direction. And opposite's true. If we put a force this way, we can get it to slow down. What is the reason or cause that most objects on Earth stop moving? Because you can't get around friction on Earth. Out in space, you can get around it, but in Earth you can't. When will an object thrown in space slow down or stop? And the idea is really not until it hits something. So how easy is it to hit something in space? Well, not until it hits something. It can, but not as probable as on Earth when it's going to hit something quite soon. In space, it could be a long while before you hit something. On Earth, you're probably going to hit something before you know it. Anyways, that is the answers to all the questions from part 1.